In today's video, we're going to be exploring how to produce figures. And so our ultimate goal is to produce a sophisticated figure like this from our data set. Something that is clearly labeled, that you can look at and kind of quickly ascertain what it is that's even being plotted here. So I'm not even going to tell you guys what we're ultimately going to plot, but hopefully by looking at this figure you have some idea of where we're going to be going today. So how do we take our data? How do we make nice, clear figures from them? We'll be covering that today. Alright, welcome back. In this video we're going to be building some figures in order to summarize the data that we've got so far from our experiment. So when last we met, we had just finished adding an old new variable to categorize our items. We also had the capacity to sort items by type. Oops, not individual item. We could do that, but we don't want to do that. By type, so blue, green, or none. Again, it's handy to center these things sometimes so that the columns line up properly, because text always goes on the left and numbers on the right, and this is just a little easier to see. But here are the likelihood that someone would say yes to a blue, green, or new item, and we can see the averages and so on. So let's say that we actually want to plot this data out, because seeing it in a table form, it can be hard to fully appreciate what's kind of going on. So in order to plot things, we need two things. We need means and standard errors. These are the two things that you pretty much always need, at least for these simple cases. Such as that we're dealing with today. So, oftentimes a pivot table will be calculating a mean for you, but in all honesty, don't trust what the pivot table's got there, just do it for yourself. So, in Excel, in order to calculate a mean, you use the function called average, and you enter this function by typing equals average and then open brackets. And now you get the option to select different numbers. Now what we're going to do is click and highlight these three numbers here. If we had more numbers, we'd keep going from different subjects, but we've only got three subjects, so these are the three numbers that we want. We close the brackets, we press enter, and now we're getting the mean for these three subjects. As you can see, it's the same as what the pivot table was computing. That's nice. Again, the pivot table doesn't always compute means. So these averages don't always line up, and for instance, if we were doing something other than plotting means, say we're doing counts, then these would be counts, not averages. So you'll need to calculate your own average anyway. So just get into the habit of doing averages for yourself. It just takes a moment. Now, once we've done it in one cell, we can do it. We can just copy and paste into the next cell beside it and get the same result. And if we click on the equation, we can see, yes, it's highlighting these numbers. If for some reason this was the wrong column, we could actually just click and move this and find the numbers that we need to average and just press enter and we'd be okay. But those numbers are all just fine. We can copy this cell and we can just paste it over here, and voila, we have our means. Now, once you have your means, the next thing you need is standard error. Standard error tells you how far scores varied from the mean. And this is important for interpreting means, because means tell you what the average response was, but standard error tells you how much individual subjects tended to vary from that mean. So those are two kinds of statistical information that are important to have. In order to compute standard error, you have to use more than one equation. So if we only wanted, for instance, standard deviation, we could use an equation called STDEV, standard ev, or STDEV. I don't know how you pronounce that. But this is Excel's equation for calculating standard deviation. And it works the exact same as for calculating a mean. You just select the cells you want, you close the parentheses, you press enter, and now this is a standard deviation. That's okay, but we don't usually want to report those. Standard errors are more informative. A standard error is a standard deviation divided by the square root of the number of scores that went into that standard deviation. So in this case, 3. There were 3 subjects, there were 3 scores that went into the standard deviation. So all we need to do to compute a standard error is to divide 0.1924 by the square root of 3. So we can actually continue to do this in Excel. So we can type divide here. Now you could whip out a calculator and find the square root of 3, but there's an easier way to do it. There's a function in Excel, sqrt, which computes the square root, and we could put in the number 3 here if we want. And this is now our standard error. And we could copy this and paste it, and now Excel's doing it for all the other subjects for us. Now that's good, but what happens if a third or fourth subject get added into this data set later? Well, then we have to go in, we have to manually correct these from 3 to 4 or 5. And again, doing manual corrections like this are kind of a waste of time. That's why we have computers to do these things. So rather than putting in 3, what if there was a way to just count up the number of subjects that were here? Well, there's an equation for that too. It's called, you guessed it, count. So if you use the equation count and you select some cells, it will tell you how many different scores exist there. In this case, 3. So let's go back up here. We're going to erase 3. We're going to type in count. We're going to select these same cells. We're going to remember to close brackets. And here's our final equation. The standard deviation of B5 to B7 divided by the square root of the count of B5 to B7. So the square root of 3. And we get the exact same answer. These equations you're going to use a lot, so get used to them. They're very simple, very easy to use, and you saw we inputted them in just a few seconds. One last stylistic thing is I highly recommend that once you've got your cells in this form, you highlight them and you right click and you go to Format Cells and you change it from a general cell to a number. The reason being is that visually when we're looking at numbers, when we see too many numbers, it's just hard to keep them all straight. It's hard enough keeping this data straight when there's only 3 cases here, but imagine you had a more complex data set and there's all these different numbers and you're trying to compare them in your head. Change them to 2 decimal places. That's plenty. And now you can more easily see what these different numbers are. It seems trivial, but again, it's like having good naming conventions. If you do it, you'll come to take for granted how much easier it makes your life. So switch it to a number cell, make sure it has just 2 decimal places. That's a better way to be looking at your data. It's easier to see what's happening. Okay, let's create a figure. So I'm going to click on a new area over here, and I'm going to click on Insert, and now I have charts that I can insert here, and there's sort of different recommended types. The kind that you want is the most basic type. It's simply a bar or a column chart. And if you click here, you get multiple options. You could do it in 3D and clustered and sideways. Essentially, the first option is what you want 90% of the time. So we're going to go ahead and select that today. So here's our chart. Doesn't look like much at the moment, but don't worry, we're about to fill it in. It's kind of a blank canvas. We want to get this data into here. So how can we do this? Well, on your chart here, you can right click and click on Select Data, or you'll see there's a Select Data option up here. It doesn't matter which one you pick, but Select Data is how you add stuff to charts. Things will look a little different on a Mac, but just look for similar buttons and you'll see that it's essentially the same. Now, what you want to do is you want to add a new series. And for the series name, we're going to call this series Blue. And if we wanted to, rather than typing it in, we could just click on this cell over here. And so in fact, that's what we're going to do. The series does not have a value of 1. It has a value of 0.56. Again, we could type it in ourselves, or we can click on the cell. And you should always be clicking on cells rather than just typing things in. Now we can add another series, and we can call this one Green. And we can click over here. We can add another series, and we'll call this Set New. And we can click over here. I'm actually typing in those items, but maybe we could go back and click on the chart instead. In fact, let's fix green. I typed in green. We're going to erase it, and we're going to click right here on the chart instead. Now, if you click OK, we have a basic chart starting to take shape. This is a good start, but it's actually a poor chart because nothing is labeled, and if someone were to look at this chart, they wouldn't really know what you were plotting. So we need to improve things a little bit. So we first need to add some labels to the axes. So you can do this by clicking on the plus beside your chart if you have that option. There's also an add chart element up here. If you go under axis titles, you can add a horizontal and a vertical title. You can add both if you like. And in fact, we're going to add the vertical first. and we're going to call this the probability of a yes. So another way to think of it is these are hit rates and a false alarm rate. Let's add a horizontal title 2. We'll call this item type. And we need something to identify what the different color bars mean. So what we need is a legend. There's different ways we can have the legend appear: at the top, to the left, the bottom, to the right. It really doesn't matter what you pick. I think I typically go for on the right. But if you go ahead and select that, now this figure is starting to look a bit better. This is showing us the probability of a green item, or sorry, a blue item being said yes to, a green item, which is in orange, which is kind of confusing, but and then we have the new items, which are in gray. If we decide we want to change any labels, we can just right click and go to select data. Here are different item types we can edit, and we can change their labels. So maybe we want to call these items new rather than have them listed as none, so we can do that. We can change their values. We can move them up and down if we want them to appear in different orders. We can uncheck some of them if we want them to disappear. There's a lot you can do with your charts. So feel free to explore and see how you can make them looking nice. We could even add a chart title if you'd like under the chart title option. And we'll call this experiment 1, let's say. Now, after plotting your means, don't stop there. One of the most crucial things you need to plot are your standard error bars. Because if somebody is looking at your two means and they're trying to mentally decide if they're different, they can't decide anything if they don't know what the error bars are. Because the way standard errors work is that if standard errors for two bars overlap, then it's likely that they're not going to be significantly different, and so it doesn't matter that the means are different. But if the error bars around means are very small and they don't overlap with one another, then it suggests there's an actual statistically significant difference there, and that's important. So make sure you're always plotting error bars. Never present a figure that just has means. It doesn't tell you anything, because it looks like there's more yes responses to blue items than green items, but without knowing anything about variability, about standard error, we can't really come to that conclusion. So how do you add error bars? Well, first click on the bars that you want, and then under add element to chart, there will be an option for error bars. And you may say, oh look, there's a standard error option, let me click that. Do not click that, it is a trap. Instead, go to more error bar options. We calculated our own standard errors, so we want to put this value, 0.11, in for the blue bars. So go down here. You could type in manually your value, and that would be okay. But again, we're more interested in clicking on cells and having Excel do things in a computational manner, so that if values change, our figure will change automatically. So rather than going with the fixed value, select custom value and then specify the value. So we need a positive error bar value and a negative error bar value. Basically, the positive error bar value is the size of the error bar starting at the mean and going up, and the negative error bar is starting at the mean and going down. We don't want these things to be 1 and 1, so just erase that right off the start. For the positive error bar value, we just want our standard error. And for the negative error bar value, we just want our standard error. So that's all you have to do, and now the error bar is filled in. And you can see now that we not only know what the average response to blue items were, but we know how much variability there was on average. So we can do the same thing for our orange bars here. Click on the orange bar, make sure it's highlighted, go to add chart element, error bars. That's a trap, so go for more error bar options, scroll down, make sure you're selecting a custom value, and then under specify value, erase what's there and select the standard error that you computed. So positive standard error and negative standard error. They should always be the exact same. And now we can do the same for new items. Make sure you don't accidentally select the mean when you're selecting your error bars. Just be vigilant so you don't make any mistakes. And there we go. That is essentially a completed, very simple chart. We've got this one here. We'll deal with that when we look at a slightly more advanced chart. But other than that, a great chart. We can see the means. We can see the error bars. We can see now that even though numerically there's more yes responses to blue items, the error bar for the green group overlaps where the mean is for the blue group. I mean, it goes up well past the blue mean. And so likely this is just random variation. These aren't significantly different. But it's likely that there is a significant difference between the blue bar and the gray bar, because the top of this error bar does not even come close to the bottom of this one. So they don't overlap. So error bars are really important for sort of visualizing data, looking at graphs, trying to understand what you've got going on here. So we're going to erase all this hard work that we just did, and we're going to try and do a slightly more difficult type of data analysis. So remember in the previous video how we sorted by whether somebody had said yes or no and looked at mean reaction time? Well, we're going to try and create a figure for that. So we have the probability of yes. It could be 0 or 1. Then we have the mean reaction times for each of our different conditions. And so we can go ahead and we can compute means and standard errors. I'm just centering everything like we did before. So mean, standard error. So use your equation or your function average to get averages. For the standard error, it's the standard deviation divided by the square root of the count of the scores that went into the standard deviation. Remember these equations. Refer to earlier in the video if you've forgotten. Once you've done it once, you can highlight these two cells and copy. And then over here, so I'm highlighting and copying. You go over here, you can just paste. You can paste. You can paste. You can paste. You can paste. Look at all the time we saved. It's very good. Here we're getting an error. We're being told divide by 0. Basically, because we only have one score, there's no way to compute a standard error. So we're just going to go ahead and put that value to 0. Although it's a bit of a cheat, in reality you'll never have a condition with only one subject. But if you ever do see an error like that, like a divide by 0 error, you've made some kind of mistake. And this is occurring right now because there's only one score going into the standard deviation, which leads to an error. So we'll set that to 0. Okay, now how do we make this more advanced figure? So let's go ahead and insert another figure here. So this time, we're going to create what's known as a clustered chart. So before, each bar was a completely different color and represented a different category. This time, we want all the blue scores in both the yes and the no options to appear as blue bars, and the green bars we want to appear together, and the new bars we also want to appear together. If you're a little confused, once I start creating this figure, you'll kind of see what I mean. So first things first, select your data, and let's add a series. So the first series that we want to add are going to be the blue bars. I'm just going to type in the labels this time so we can see them a little more clearly. And before, we just clicked on a single bar. Rather than doing that, I want to click on more than one bar. I want to have both the no's and the yeses from the blue category belong to this series. So the way I do that is after clicking on one value, I hold the control button and I click on the next value. And you can see now I have two cells selected, and in the series values it says sheet B13, comma, F13. And I'll click OK. Now let's do the same for the green bars. I want to have two green bars represented. And by the way, if you'll notice, look at the blue bars, right? These are two different bars representing the response time to blue items. This is when people said no. This is when people said yes, right? When people said no, when people said yes. Let's do the same with the green items. So we'll click on the response time when people said no. We'll hold control and click when people said yes. Okay. Let's do this one more time and we'll add in for the new items. Click there, hold control, click there. Oh, in fact, I had that in the series name area. I'm going to erase that and fix this. There we go. And let's just click OK and see what we've got so far. So here are the different reaction times. And you can see figures help you visualize things a little more easily. If you were just looking at these numbers, and by the way, we should change these to number cells. to make sure they only have 2 decimal places. They're easy to read. But if you're just looking at these numbers, it might be hard to see the overall pattern that's occurring. But once you look at the figure, you can clearly see, oh, the green items are getting really slow here, but everything is about the same speed over here. And also, things are generally slower over here than over here. So figures are very helpful when trying to look at overall patterns. Okay, now this figure is still hard to read because it doesn't have labels. So we need to label things. So let's go ahead and add a legend, because legends are very helpful. Let's also go ahead and label this bottom category axis. Rather than 1 and 2, that's confusing. What were these different categories? I don't remember already. So how do we label these 1s and 2s? Change them from 1 and 2 to actually mean something. Well, we do that in the select data area. And look over here, horizontal category axis labels. It's given the values 1 and 2. We want to edit that. 1 and 2 are terrible labels. Instead, the first was for the no responses, and this, so let's do it like this. No responses and the yes responses. So notice that I'm typing in quotation marks and I'm putting a comma between my labels. And if I click enter, now those 1 and 2s have changed from these are the no responses and these are the yes responses. So now I can see, oh, when a blue item was said no to, here's its average speed. When a green item was said yes to, here's its average speed. When a new item was said yes to, here's its average speed, and so on. So we've now created a very nice clustered figure, and we're labeling things as we go. We need a vertical axis label so we know exactly what we're plotting. So we'll go here and select the vertical axis, and we'll call this mean reaction time. And the last thing we need are the standard errors. So just like before, we're going to click on a colored bar, in this case a blue bar, and look, it's selecting both of the blue bars. So when we add our standard errors in here, we're going to actually have to add 2 standard error values. So remember, don't select standard error, it's a trap. Go to more options, scroll down, custom, specify that value, erase what is already there. And for the positive value, remember, we want the standard errors of our 2 blue bars. So we first want to click here to get the first one, and then we hold Control and click over here, just like when we were selecting the means. We clicked on this mean and we held Control and we clicked over here. So you do the same thing for the error bars. And now we can see the error bars for our blue items. We'll do the same thing over here. So I'll show you one more time so you can see, and then I'll just do the new items by myself. But I'm erasing what's already here. I'm clicking on one standard error, holding Control, clicking on another, and then I do it again. And now I'll just very quickly do this for the new items. And here's a little trick. After you've entered it in once, you can highlight this and copy it, and then you can just paste it down there if you don't want to be clicking all over the place. And there we go, voila! Now we can see the mean reaction times to our different categories of items, and our figure is nice and clearly labeled. We can see the error bars, and now we can visualize this and say, whoa, it looks like there might be a statistical difference between how slow the green items were and how fast the new and the blue items were. But the new and the blue items aren't significantly different here. But when there were yes responses, probably there's nothing different. I mean, statistically, maybe this and this are different, but we had a problem here where we couldn't compute an error bar, so don't trust that. Again, go through this process. It's important that you're clicking on the cells, because if things update, let's say this error bar changes, look, our figure will just change for us. We don't have to go in and do anything. So by making sure you're following the correct steps and setting your file up initially correctly, as your data might get more filled in, you can just allow the charts to automatically update, and you don't have to worry about things. Now, if you want to dive more into Excel figures, there are plenty of tutorials on YouTube. This is the only one I'm really making for us, So feel free to explore on YouTube or Google if you need more advanced help. But as far as getting basic figures going, this is really the building blocks of everything that you need. And I use all of these techniques on a regular basis to produce figures myself. Also, though, feel comfortable to make figures in R if you're more familiar with that, or any other program that you want. Really, it doesn't matter where you make your figures, so long as you are following the basic best practice guidelines of labeling everything, making everything as clear as you can. Have a legend. Label your axes. Label your vertical axis. Make sure you have means and error bars. And I don't just mean label this RT. Notice I labeled this mean RT. I'm trying to be as descriptive as I can in as small a space as I can. So when you look at this, you know that this is an average reaction time. It's not perhaps maximum reaction time or something like that. So make sure you're labeling things as clearly as you can. It will really make your figures a lot easier to comprehend, and you'll do a lot better in things. Anyway, that's it for today. In the next video, we'll be exploring some more advanced topics when it comes to experiment design, and so we'll see you guys there.